Super Science Smorgasbord Lesson 3, Weather, the Cloud in the Bottle Hook Teacher Demonstration Activity. Again, our activity learning objectives, which are the objectives that we hope the students learn and can explain by the end of the lesson, are that students will be able to describe that clouds form as air moves from the ground to the sky and molecules or water vapor expand and condense around dust particles. Hi, I'm Josh Morris with Science Matters, and this is Super Science Smorgasbord Lesson 3, all about weather. The first activity in this lesson is a teacher demonstration, and we're going to make a cloud in a bottle. For this activity, you'll need a foot pump, a 1-liter clear plastic bottle that also has this valve stem and rubber stopper apparatus inside of it. You will then need a pipette and just a little bit of rubbing alcohol. So weather is all around us, and weather happens because of the movement of air. Maybe it becomes windy outside, maybe it becomes cloudy outside, it gets hot, it gets cold, it'll snow, it'll rain. All kinds of weather happens every day all around us. And the reason why weather happens is because of the movement of air. If a high pressure system comes in and settles over the area, that means that air is moving from the sky towards the ground. And high pressure usually means pretty good weather. When a low pressure system moves in, that means air is moving from the ground to the sky. That usually means we're going to have a change in weather, and maybe the weather won't be so good. And the reason why is as that low pressure system comes in and air moves from the ground towards the sky, that air starts to expand and condense. And that condensed air that contains water can condense on dust particles to make clouds. The more clouds we form, the more chance we have of actually having some type of weather event. So for this demonstration, we're going to make a cloud inside of this bottle. So we need something that can expand and condense on dust particles in the air to make that cloud. So we're going to do that with just a little bit of rubbing alcohol. We could use some warm water, but the rubbing alcohol evaporates just a little bit quicker, and that'll help us do this demonstration just a little bit faster. So I'm going to use my pipette and put no more than 5 drops, just 5 small drops of the rubbing alcohol down into my bottle. I'm going to take the bottle and just give the alcohol a second to evaporate. I'm just going to kind of move it back and forth, let it coat the inside, let that liquid evaporate into a vapor. Maybe hold the sides and heat it up just a little bit. And now we have some evaporated alcohol. Again, this would work with water, and it really is water in the air that starts to form a cloud. Now, we need to build up pressure in this bottle, only so that we can let the pressure out so we get that expansion and that condensation to form a cloud. So I'm taking right now my rubber stopper and valve stem apparatus. I'm actually screwing it into the foot pump. I'll lock it into place, stick it inside of my bottle, and now we're good to go. You're going to use the foot pump to build up pressure inside of the bottle. So you're going to have to hold on pretty tight with your hand that is holding onto the stopper to keep it down inside of the bottle. The first time you do this and practice this at home, maybe only do 5 pumps. Remove the stopper and see what you get. By the time you're ready to do this in class, you want to do anywhere between about 10 and 15 pumps to build up enough pressure in the bottle. So here we go. We'll count. We can have the students count with us. And as we start to pump, we're building up pressure in the bottle. We're actually squishing the molecules inside closer and closer together. Now, we're doing that so that in a minute, they can actually spread out when we remove the stopper from the top. We'll give it about 2 more good pumps here. And now we're ready to go. So we quickly remove the stopper, and as soon as we do, all that pressure that was built up, released from the bottle, all of that gas inside can expand and condense on some dust in the air, and we get our cloud in the bottle. This is Super Science Smorgasbord Lesson 3, Weather, and this is the wind vane and anemometer take-home activity. Our activity learning objectives are that students will be able to observe and explain that differences in air pressure create wind that blows in a specific direction at a specific speed. So our next weather device for Super Science Smorgasbord Lesson 3, all about weather, is a wind vane. Students are going to be able to measure what direction the wind is coming from as they take their weather data. In order to do this activity, which is again is a take-home activity, each student will need a styrofoam cup. You're going to need a sharpened pencil, and I'll show you that in just a second. Students will also need an unsharpened pencil. We'll need a straight pen, which is pretty small. We're also going to be very careful with those. We're going to talk about those again in a minute. We'll need a straw, a pair of scissors, a little bit of Scotch tape. And then the last thing we need is a piece of paper in which you're going to cut out the tail of the wind vane and you're going to cut out the tip of the wind vane. Now, in terms of prep for this activity, before class, I'm going to take a sharpened pencil and I'm simply just going to poke it down into my styrofoam cup. That way, when we're ready to go in class, the cup already has a hole inside of it. I'm also going to make sure that I take the sheet of paper that has all of the wind vane tips and all the wind vane tails and go ahead and cut those out before class as well. And then, depending on the level of students that I have, I might also go ahead and take my scissors and the straw and just put about a 1-inch snip on each end of the straw, making sure that both of those cuts are parallel to each other. So now when we're ready to go in class, we'll pass out all the items to the students. The students can then take their unsharpened pencil, they can place it down inside of the styrofoam cup and add a piece of Scotch tape just to hold the pencil in place. I've already done that. So we'll switch those two guys out and now we're ready to go. The next thing the students are going to do is take the wind vane tip and the wind vane tail, slide those into the slits that you've cut into the straw, and again, just taking a piece of Scotch tape, attach the tip and the tail to their straw. Now the last step might need a little bit of your help. I would probably come around and take the straight pin and actually put it inside of the straw for the students, and then work with each student to carefully take it and slowly push down into our eraser inside of our pencil. And there we have it. We have our wind vane. We want to make sure that the pencil doesn't move and that the straw spins around the straight pin. One last thing we're going to do is we're going to have the students take a pencil or a marker, and on the cup they're actually going to mark north, south, east, and west, so that when they get home, mom and dad can help them point the cup in the correct direction, so that north is pointing north, so that their wind vane can show them which direction the wind is actually coming from. And the last weather device we're going to make for our weather lesson from Super Science Smorgasbord is an anemometer. An anemometer is nothing more than a wind speed meter. Obviously, we could do some fancy physics and figure out actually how fast this is going to spin, but for our students, we're just going to talk about, is the wind calm, is the wind blowing moderately, or is the wind blowing strongly or very fast? So in order to make this, you're going to need, again, a styrofoam cup. As a teacher, you'll need a sharpened pencil for a little prep. The students will all need one unsharpened pencil. Each student will also need a paper cup, 4 of the little 1-ounce plastic cups, 1 straight pin, 2 straws, and then again, as a teacher for some prep, you'll need a hole punch, and then we'll use some Scotch tape along the way to put everything together. So just like making the wind vane, the teacher beforehand, with a little prep, will take the sharpened pencil, again, poke a hole in the cup, so that again, in class, the students can simply take their unsharpened pencil, place it down in the cup to hold everything in place. Again, I would take 1 little piece of Scotch tape to hold everything together, and again, there we go. Now, another item of prep is to take the cup and do 2 things with it. Number 1, again, we're going to take the sharpened pencil and just poke a hole in the bottom. Again, this cup's going to set down on the student's unsharpened pencil. So we just want to spin it around and make the hole big. We're also going to take a hole puncher and we're going to punch 4 holes around the rim of the cup. These holes are going to be kind of like north, south, east, and west. So they're going to be 90 degrees to each other. So I'll poke those 4 holes. And now in class, the students can take each straw and thread them through the holes from one side to the other. They'll do that twice, and when they're finished, they'll have something that looks like this. Then the last step is they're going to go ahead and take their 4 1-ounce plastic cups and tape them on to the end of the straws, all pointing in the same direction to make our anemometer. Once we do that, the teacher can come by with a straight pin, poke it through the 2 straws, and now we're ready to go. And our last step is to take the cup with the hole in the bottom, simply slide it over the straw, or excuse me, slide it over the pencil until the straight pin and the straws meet the eraser. Then we take the straight pin and poke it right down into our eraser. So now we have our anemometer. It can spin. Again, we're going to have to do a little work here to kind of smooth everything out. Let the students spin it around in class. So by the time they get home and the wind blows, the anemometer can spin to show them how fast the wind is going.